This conference will now be recorded.
Yeah. So we were talking about Java being object-oriented programming, right? Okay. So when you say that Java is object-oriented program, if it is totally developed on the basis of class and object, right? Okay. Java is an object-oriented programming language. Yes. So Java is a object-oriented. So in short, what you can call it? You can call it OOP, right? You can call it OOP. Okay. So Java is said to be an object-oriented programming language as it is developed using a class and an object. A class and an object. So why Java is object-oriented programming language? Because it is totally developed on the class and object. So where a class is a simple, we can say, blueprint. Okay, so class is a blueprint for creating the the class is a blueprint for creating the objects. Okay, so class is a blueprint for creating the object. So for example, you have class student. Okay, so you have something like class student. So class student. So who is class now? So class is a blueprint. Class is a blueprint. So now what I said, if you want to create the object out of this class, what you will do? So you will use public static void main. Okay, and you will write something like string args, and then how you can create the object over here? You can create the object by using the student class. Okay, by using student class. So student s is equal to new student. So class student is equal to new student. So this is the way that we create the object. So this is the object. So we will be using in our course, we will be using the objects, we'll be using the classes. Okay, so in a big way. So we will be doing that later. So for now, we need to understand the other features also. Okay, right. So Java is, okay. Who is this now? This is going to be the object. Okay. So what is this? This is the object. Object of which class? This is object of which class? Object of student class. Object of student class assigned to yes. So who is yes here? Yes is a placeholder. Yes is a placeholder, or yes is a object variable, simply you can say. Yes. Okay, we'll talk more about it. We'll talk about how to create the classes, how to create the objects, and how we can use the objects to access the data, methods, etc. Okay, so today we will talk about the next feature, which is Java is compiled and interpreted. So what is Java, sir? Java is compiled and interpreted. Okay. Now, if you remember, I told you, whenever you are writing a Java program or any program for that matter, okay. So if you are writing a Java program, or if you are writing a C program or a Python program, so it is not directly understood by the system. It is not directly understood by the system. Okay. So now what you need to do? So you need to go for conversion. You need to go for what? Conversion. So whenever I'm saying conversion, so you need to convert that into machine code or any other code for that matter. Okay, right. So first of all, we need to understand what is compiler and what is interpreter. Then we will understand what exactly Java will deal with those. Okay. So first we will talk about compiler. So what is compiler? A compiler is a piece of software. Compiler is a piece of software that is used for converting the it is used for converting the source code. What do I mean by source code? Source code means what you write. What you write. So you are writing some source code, and that source code is being converted into some other code. Okay. So converting the source code into machine code. Converting the source code into machine code or byte code. So what is machine code? What is bytecode? We will understand. So what is a compiler? It's a piece of software that is used for converting the source code into machine code or bytecode. Okay. So now, in which case it will convert to machine code? In which case it will convert to bytecode? What is bytecode? We will understand. Okay. So in C language, in C language, the source code is converted into machine code, not into machine code. The source code is converted into which code? Into the machine code. The source code in C language, the source code is converted into the machine code, and in Java, the source code is converted to source code is converted to byte code. Source code is converted to which code? Byte code. So in C language, the source code is converted to machine code, and in Java, the source code is converted to byte code using a compiler. Using a compiler. So what exactly you are talking about, sir? Here. Okay. Now let me make you understand. So now, for example, I am writing a C language code. Okay, if I'm writing a C language code, so generally C language code will be something like int main. Okay, so and you'll have something like return 0, and you are going to use something like printf hello something. Okay, so this is C code. So C code will be saved as program dot C. Program dot C. So C code will be saved as what? Program dot C. So this is called the source code. The source code is nothing but which is written by the programmer. The source code is nothing but what? Which is written by the programmer. Yes or no? Now, now the next question is this directly understood by the system? So the answer is no. So it is not directly understood by the program. So program will not understand this. Program will not understand this. So what program will have to do now? Program has to convert this into machine code. Program has to convert this into machine code. So in order to make the program converted, what we use? We use the compiler. What we use? We use the compiler. So what a compiler will do, sir? Compiler will convert the source code into which code? Into the machine code. Into the machine code. So what kind of machine code, sir? What is machine code? Machine code is nothing but ones and zeros. Ones and zeros. So it will convert everything into machine understandable language. Is that clear? So this generally is known as program.exe. Okay, so this is known as what? Machine code or executable code. It is known as which code? Machine code or executable code. Am I clear? What a compiler is doing, sir? Simply Compiler is converting the source code into machine code or executable code. So whenever I'm talking about machine code or executable code, which is directly understood by the system, which is directly understood by the system. The system directly understands whatever you are writing. Am I clear? So now we will look at how the system will look at it. So now if you observe here, the system will be linking. The system will be linking. So who will be linking, sir, here? OS. Your OS will be there, no? Who is OS? Like Windows, Mac, Linux. Okay, so all these are operating systems. So what operating system will do? Operating system will link this and will give you the output. Will give you the output. So what is the output in this case? In this case, the output is hello. Getting my point? Is this clear? So this is the C language. This is the C language. So what is compiler in simple terms? Compiler is a converter. Compiler is a converter. Okay. So why you require converter? Because you are writing the code which is not understandable by the system. As it is not understandable by the system, so what we need to do? We need to convert. We need to convert. So once we convert, that will become machine code. So that machine code will be linked by the OS and will give you the output. Yes or no? Understood up to here, everyone? Okay. Now let's see. Whenever we are talking about the compiler, okay, so so whenever you are talking about compiler, this is the case. So what happens in Java, sir? Now in Java, okay, so in Java, the source code is converted into an intermediate code. Converted into which code? Intermediate code. So in Java, the source code is converted to an intermediate code called bytecode. Called which code? Bytecode. So bytecode still is like source code which is not understandable by the system. Okay, so which is not understandable by the system. So what we have to do? We have to again convert that into machine understandable code. Okay, so called bytecode. So how, sir, how it will take place? Now let me make you understand again. Now what you are writing? You are writing the Java code. Okay. So in order to write the Java code, what I told you we'll have to create the class. Okay. Now for example, if I'm creating class employee. Okay. So now I will have something like public static void main. So what is this public static void main and all? You will understand later. Okay, so now I will say system.out.println hello, something like this. Yes. Okay, now what is this code? This code is nothing but program.java. What is this? Program.java. Program.java. Okay, now this Java code is called as the source code. Is called as the source code. So this Java code is called as the source code. So now this source code is converted to what I told you, bytecode. Okay, so this will convert into bytecode. So whenever I'm talking about the bytecode, so what I'm talking about an intermediate code. Intermediate code in the sense it is not the source or it is not the output. Okay, so it is nothing but some bytecode. Okay, so bytecode is always in bytes. Okay, always in bytes, so it will be in terms of some bytes, right? Okay, so it will be some characters. Okay, so it will be some characters which will not understand generally. I'll show you when the program runs. I'll show you. So this is becoming, okay, who is getting it? Compiler is getting it. Who is getting it? Compiler is getting it. Okay. So now here I will say program dot class file. Program dot class file. What is this file? Program dot class file. So this is a program dot class file, and this program dot class file is known as which code, sir? Is known as the bytecode. Who is responsible for getting this? Compiler. Okay. Now this is not directly by the system again. This is also not understandable by the system. So then what has to be done? It has to be interpreted. No, still it is not machine language. It has to be interpreted. It has to be interpreted. So interpreted into into the machine level, into the machine level. So this is not like uh, you will not be looking at this. Okay, so system will take care. So generally this you can see, this exe file you can see, but what you can't see, you can't see this particular file. Okay, but system will interpret it, system will interpret. So now what is the process? The OS should link it, the OS should link it, and after linking what you get? Okay, so OS will link it and you will get the output. You will get the output. So what is the output in this case also? In this case also it is hello. Yes. So how to create that class and all later. For now, just try and understand the things. Now C means, what is the difference between C and Java? You understood now? Directly it is converting into machine code. But in Java it is not directly converted into machine code. It is converted into bytecode, and that bytecode will be interpreted, and that will come to OS, and then you will get the output.
So even the compiler has the capacity to convert into do the work of interpreter as well.
Yes,
Then why the
yes.
work is
I'll
replaced?
tell. I'll tell you. I'll tell you. So I'll come back to your question. Okay. So in the next feature, I'll come back to your question. Okay. So now compiler in Java. Okay. So compiler in Java, which we call it as Java C. So what is Java C? So Java C will get the class into bytecode, and this bytecode will be converted into machine code by using Java interpreter. Okay. I'll come back to your question. Yes. Okay. Now the next question is, what is interpreter and what is the difference between compiler and interpreter? That is the next question that we need to talk about. Okay. Now what you got? You got a class file. You created a Java file. You created a Java file. You got a class file. You created a Java file. You got a class file. 2 points. Understood? You created which file? Java file. You got which file? Class file. Okay. Then what we are doing over here? So we are going for the conversion of into the machine code by the interpreter. What is the next question that we need to answer? What is interpreter? What is interpreter? Okay. Interpreter. It is a piece of software that converts the byte code of Java or Python. Java or Python. So that converts the bytecode of Java or Python into machine code. Into machine code. Right? Okay. In case of Java, we use, okay, otherwise we'll write this point later. Now we'll talk about Python also. Okay. So in Python, okay, A is equal to B, sorry, A is equal to 6, B is equal to 3, and I will say print of A plus B. Okay. Now this is Python source code program.py. Okay, program.py. So whose source code? Python source code, right? Okay. Now here you will not be looking at compiler. You will not be looking at what? Compiler. So you will be looking at interpreter only. You'll be looking at interpreter only. So that interpreter will convert into bytes. Okay. So now this is called program dot class. Program dot class. So this is also bytecodes. But who is responsible for bytecode in Python? Interpreter. Yes. Okay. And this will be converted back again into machine code by interpreter, not compiler, by interpreter. So here only interpreter. Here no compiler is there. Okay. Then we will be linking by OS, and that OS will give the outputs. Clear? So linking is done by the OS and give the output. So it is a piece of software that converts the bytecode of Java or Python into machine code. In case of Python, the bytecode is generated by, so in case of Python, the bytecode is also generated by interpreter. Is that clear? But we generally don't talk about interpreter converting into bytecode in Python much. But anyhow, you don't have to worry because you are Java students. Okay, so Python students will worry about that. Okay, now the next thing, what is compiler, what is interpreter? So you see that both of them are doing same kind of job. Both of them are doing same kind of job. Then what is the difference? Okay, now the next point is compiler versus interpreter. So compiler versus interpreter. So what we are going to talk about next, what is compiler, what is interpreter, what is the difference? What is compiler, what is interpreter? You understood already. Yes, what is compiler? Conversion. Interpreter, conversion. Both are converting. But what is the real difference? Okay. Now I'll tell you a very simple and easy example. Now if you want to come to this third floor of the building, so you will come by either lift or you come by steps. When you're coming by lift, you are coming block by block. When you're coming by steps, you are coming one by one. I mean, step by step. One step, one step, one step. Like that. Now, the same difference lies with compiler and interpreter also. Compiler converts the code in blocks. Interpreter converts the code line by line. Yes? Okay. So, a compiler converts the code block by block, block by block. So a compiler converts the code block by block, right? Whereas, whereas, a whereas an interpreter converts line by line, line by line, converts line by line. Yes. Okay. Now, for example, if I am writing some code, let's say I will write block 1, block 2, and block 3. Okay, so let it be block 1 and block 2. Now when the compiler is at work, what compiler will do, so it will convert block 1 and block 2. Yes, but when the interpreter is at work, so let's say I have same thing b1 and sorry, so b1, so b1 and B2, let's say. Now it will convert line by line. So B1, suppose say 5 lines are there, and here 3 lines are there. Okay. Now it will go 1, 2, 3, 4, 5, 6, 7, and 8. So it will go line by line. The conversion takes line by line. Understanding my points? Is it clear? So whenever I am talking about interpreter, it goes line by line. Now tell me who is faster?
Couple.
Compiler is faster. Who is faster? Compiler is faster because it is going block by block. No, one block, second block, third block, fourth block, fifth block. Any number of blocks it can carry out. Is this crystal clear?
Yes.
Yes. Okay. Now, as we see, both of them are converters. Both of them are converting in their own style. In their own style, we can conclude that we can conclude that the compiler is faster. Compiler is faster when compared to interpreter. So who comes by lifter will come faster, no? Yes or no? So the one who comes by steps will be slower. Okay. Now what about C? C is only using compiler. Yes or no? So it will be very fast. Okay, or otherwise I'll write fastest. Yes, okay. Now I will say Java. What Java uses? Java uses compiler plus interpreter. So it is faster. I'll not use the word slower because slow means it should be like tortoise. It is not like that. So it is like 3 rabbits at a time. One rabbit is faster than the other. One rabbit is faster than the other. That's it. So three rabbits are running. So 3 rabbits are running. So 3 of them are fast only, but one rabbit is more faster in that way. So we'll not say slower. We'll not use that word slower anywhere. Yes. Okay. Python. What it uses?
Interpreter.
It uses interpreter. So I will say fast. Fast, faster, fastest. Okay. So if you say C, C is faster than Java. Java is faster than Python. Is that clear? Is my point clearly understood now? Yes or no? Yes. Now you understood what is compilation and what is interpretation. What is compilation? Convert source code into, okay, convert source code into, understood? Fast, faster, fastest. So fast, faster, fastest. Okay. Now, now whenever I am looking at here, okay, so whenever I'm looking at here, we see that compiler is there, interpreter is there. So compiler will do the job, interpreter will do its job. Okay, so all that. Now coming back to your question, sir, compiler is there, no? So Java can use both compile only compiler to make it fast, but the architecture is there. So C has some architecture, Java has architecture, Python has some architecture. So C is supported by the compiler. C architecture is supported by the compiler only. Java's architecture requires compiler also and interpreter also. Python architecture requires only interpreter, means line by line conversion. So Java requires one compiler for converting to bytecode, and that bytecode is to machine code. So the architecture, it all depends on the architecture of the program. You say memory architecture, you say structural architecture, you can say anything. So it depends on the program architecture literally. Understanding? Okay. And the next reason why Java is both compiled and interpreted, we will come back to that. Okay. So next, Java is platform independent. What is Java? Platform independent. Okay. Now this is the next reason why the architecture is supporting both compiler and interpreter. Okay. Now when I say platform, so what do you mean by platform? Platform is the thing where, suppose now for example, this is a platform. This is a platform of learning. This is a platform of teaching. Yes. So now in the same way, every system has a platform. Every system has a platform. So now, for example, this Windows. So where we are running, we are running in Windows. Now somebody will have Mac OS. So they are running in the Mac environment, Mac OS environment. Yes. Understanding my points? Yes. So Java is platform independent. Why sir you are calling it like that? Means Java can run Java program once I create, so it can be easily run in any platform. So that is what my point is. Okay. So first of all, we will know what is a platform. A platform is nothing but an environment, nothing but an environment where the programs can be developed and developed and executed. Programs are developed and executed. So Windows is a platform. So Java is also an environment basically. So Java can also be regarded as a platform, sorry, environment. Can be also regarded as an environment, as an environment. So Java can also be regarded as some environment. It also be regarded as some environment. Okay. Right. Okay. Now, why Java is called platform independent? So Java is platform independent since the generated bytecode, can be executed in any of the platforms. Okay. So here I'll tell you one example. So that is how it can be easy. Okay. So example, Windows, Mac OS, Linux, etc. Right. Right. So Java can be platform Java can be platform independent. So platform independent since the generated bytecode can be executed in any of the platforms. So what I'm talking about, sir, here. Now, for example, you are a programmer, let's say. So you have created a Java program. You have created a Java program. So this Java program will generate which code? This Java program will generate which code, sir? This Java program will generate a bytecode. Okay, so now this bytecode, let's say this is developed in Windows. Now where the bytecode is generated in? Bytecode also generated in Windows only. But what we can do, so I can take this bytecode and interpret in Windows. I can interpret in Mac. Okay, I can interpret in Linux. I can interpret in Solaris. So I can interpret in any any platform. Okay. So Windows platform, Mac platform, Linux platform. So on any platform I can do it. Is this clear? Yes or no? So that is why, so this interpretation. But every interpretation requires what? Requires a JVM. What it requires? JVM. So JVM. Yes. Understanding my point? What every thing requires? JVM. So JVM and all. Okay. So tomorrow we will be downloading and installing Java. So if you get laptops, so we'll do that in our next session. Solaris. PSOLERAS. Okay. Understanding? Okay. So Java is platform independent since its generated bytecode can be executed on any other platform. Bytecode, not the source code. So always remember after the compilation only. Okay. So here JVM means a Java virtual machine. Java virtual machine that should be a part of every platform which to be which needs to be available which needs to be available should be a part of every platform which needs to be available for execution of the bytecode execution of the bytecode. Understanding my points? Yes, for execution of the bytecode Java virtual machine is very important. Okay. So JVM comes with what? With the installation. Okay. Now once you install Java in your system, so try to understand this. When you install Java in your system, okay. So what you are installing, let's say Java is installed in your system. So once you install Java, what happens? So you get the development environment. What you get? Development environment. So you get the Java development environment. What do you get, sir? Java development environment. What do you get? Java development environment. So now what is Java environment development, sir? You will get APIs. What you will get? APIs. So what are APIs? APIs are nothing but application programming interface. Libraries we say generally. So that is what it is. Okay. And then you also get, so this is Java environment. So you also get Java runtime environment. Java runtime environment. Java runtime environment. So you get Java runtime environment. We call it as JRE. JRE. So JRE, so JVM is a part of the JRE. The JVM is a part of the JRE. Yes. So in the JRE, JVM will be there. So that JVM will take care of this execution. JVM will take care of this execution. Yes or no? So development is responsible for developing the source codes. Okay, so JR is responsible for running or execution. Understanding? Yes. Hope you're understanding my points. So Java is the environment where we will have the development environment as well as the runtime environment. So development environment, what it will do? It will work with the program development. Runtime environment will work with the program running. Program running. Is that clear? Yes. Understanding or not? Please tell me. Okay. So this is how we deal with the program running, program execution, and all those things. Understood now? What is the difference between compiler, interpreter? What is the difference between them? You understood? So very important question they'll ask you. Okay. So if they wanted to really test your knowledge on Java architecture, they will definitely ask you this. Okay. Right. So next we will talk about the next feature, which is going to be exception handling. Okay, so we'll just introduce this concept, and in our next session we'll talk in detail about this. Now, before going to exception handling feature, I will talk about errors. I'll talk about errors. So generally, what is an error? Error means a mistake. Error means a mistake. Error means a mistake. Okay. So first we'll talk about, just I'll introduce this topic. So tomorrow we'll have a clear understanding. So an error is a mistake. Error is a mistake. An error is a mistake that takes place in the program. Error is a mistake that takes place in the program intentionally or unintentionally. Intentionally or unintentionally. So wantedly we sometimes do mistakes. Sometimes without our knowledge the mistakes will be coming. Yes or no? So error is a mistake that takes place in the program intentionally or unintentionally. In Java, we come across we come across three types of errors. We come across three types of errors. First one, syntax errors or compile time errors. Okay, so syntax errors are compile time errors. Next, exceptions are, just I'll summarize these things. In detail, we'll discuss tomorrow. Runtime errors. Okay, so and then we will talk about logical errors. Okay, so as I've told you, I will just sum up the things. Syntax errors or compile time errors. The errors that will come in the program when you are not following the rules. When you are not following the rules. So every programming language have some set of rules. So if you're not following those rules, if you're not following those rules, so what will happen? Syntax error will occur. What will occur? Syntax errors will occur. So if you're not following the rules, what errors will occur? Syntax errors will occur. Am I clear? Yes or no? So if you are not following the rules, what errors will occur? Syntax errors will occur. So this syntax error will occur at the time of what? At the time of compiling the code. What do you mean by compiling? Compiling means when you are converting into bytecode. At that time, that errors will be coming. Is that clear? Okay. Point number one, syntax errors. Point number two, exceptions or runtime errors. When you are running the program, after the bytecode is generated, when you are running the program, you will run the program for output, no? So when you are running the program for the output, you will get these errors. So these errors are the errors where the system do not understand what to give. System do not understand what to give. For example, if I say 10 by 0. So what is 10 by 0? Generally infinity, no? 10 by 0 is generally infinity. But system does not understand what to give. At the time it will give you runtime, right? Then logical errors. What are logical errors? The errors that will come up in the program when you are writing the logic. When you're writing the logic. So if your logic is wrong, if you are getting the output, but that output is not the expected output. So you are not expecting that output, but you got that output. So at that time, there is some difference in the logic. So we will talk about this and we will also discuss who is more dangerous and what we can do with this. Okay, what kind of exception, if this kind of exception is coming, what to do? If this kind of exception is coming, what to do? If this kind of exception is coming, what to do? So we'll discuss about everything in detail in our next session. Okay, thank you. Yeah, Jagdish, Prashant, Harshita, hope everyone understood. Okay, so we'll meet tomorrow with more discussion on this. Thank you.